This video is on proofs. Quite often we state things as fact, like an odd number plus an odd number is an even number, but sometimes that just isn't good enough, so we need to mathematically prove it. How do we do that? Using algebra. First, we need to define what odd and even numbers are. Even numbers are pretty simple, as all even numbers are divisible by 2 by definition, they can be expressed as 2n. So for 2, n would be 1, for 4, n would be 2, and so on. Well, what about odd numbers? Well, if you take an even number and add 1 to it, you get an odd number as it's not divisible by 2 anymore. So all odd numbers can be written as 2n plus 1. Even in 1, because in that case n would be 0. 2 times 0 plus 1 is 1. We can also use variations on these, like 2a and 2b plus 1, as n isn't an actual number, it's just a variable representing an unknown. Using these definitions, we can prove some facts about odd and even numbers by replacing odd and even in our equations with the actual algebraic expressions. Then, with our answers, if we factorize out 2, we can express the answer as either 2n or 2n plus 1, allowing us to say that the answer will always be even or odd. This is the basis of proof by deduction. Proof by deduction uses known facts, like our definitions of odd and even numbers, to prove larger, more complex facts. Occasionally you'll need to use more than one fact, which we did just then, and these facts will need to be written as algebraic expressions, which is why we had 2n and 2n plus 1. This allows us to combine and manipulate them. Another example is that rational numbers can be written as p over q, where p and q are integers. As rational numbers, by definition, are expressed as a ratio of one to another, this is just a way of representing that allows us to do our proof. So, what will you be asked to prove? Usually, it'll be one of two things. The first is proving that a statement is true or that the result has a certain trait. This common trait will usually be something to do with whatever traits they tell you that the numbers you're using have. If the two numbers going in are labelled as odd, they may ask you to prove that the result is odd, for example. The other thing they'll ask you to do is prove that a statement is divisible by something. This is somewhat of an extension of asking, is the answer even? You'll need to factorize out the number that you are checking that it's divisible by. Most of the time though, if it asks you to find that it's divisible by something, or prime or anything like that, you use proof by exhaustion instead, which I'm going to move on to now. Proof by exhaustion comes under two main types. The first is using algebra to test an equation for every possible value. For example, you can test it where x is 2n and x is 2n plus 1 and check that the result fits the criteria in both cases. As this is the formula for odd numbers and even numbers, then you have covered every single number that there is. In fact, you usually use the odd and even formulae to prove, but if it's asking you to prove that the answer is a multiple of a number, you'll need to use a different formula instead. So, if you're checking that it's divisible by 4, you'll use 4n, 4n plus 1, 4n plus 2, and 4n plus 3, as 4n plus 4 can be expressed as 4n, and thus loops back around. Sometimes, though, you test every value manually. This will always be for a given range, as otherwise you'd be trying infinite values. Sometimes it will be every value in that range, but quite often they narrow it down by asking you for only every prime number or every even number. So if you're given a range, then you just need to try the statement for every kind of value they ask for. It's essentially trial and error, except without the error, as you're not being asked to determine whether or not it is true, just to prove that it is true. It's essentially a show that this is question. But what if it isn't? What if it's not true? In that case, we use disproof by counterexample. We're showing exactly why it isn't true. This involves finding a case under which the equation breaks down. You'll know you have a disproof question because they will specifically ask you. The question will say to prove that the statement is incorrect, rather than that it is true. This one is essentially trial and error, as you need to test the equation under various circumstances to see which one doesn't work. However, instead of just trying numbers randomly, here are some tips to help you out. One of the easiest and most common ways to disprove a statement is to test it with a negative number. If the statement involves moduli or inequalities, this is probably what they're looking for, although it may also be needed if one of the terms in the statement is squared or square rooted, as when a number is squared, its negativeness is essentially ignored, so the statement may have forgotten to take this into account. You can also mess around with what factors your numbers have. This is especially handy when it's asking you to disprove that it's divisible by a certain number. The best way to explain this is with an example. Say that the statement is that if x squared is divisible by 4, then x will be divisible by 4. In that case, one of the ways to disprove that would be to set x equal to 6. X squared is 36, which is divisible by 4, but 6 itself is not divisible by 4. The reason for this is that 6 is 2 times 3, so 6 squared is 2 times 3 times 2 times 3, or 2 squared times 3 squared. 2 squared is 4, so it's divisible by 4. This should show that you need to think of numbers in terms of prime factors. The prime factors of 6 are 2 and 3, and while the prime factors of 4 are 2 and 2. So the number going in, because it's going to be in the equation twice, should have a 1, 2, so that it's not divisible by 4, but then the answer will be divisible by 4. So what you need to do with your factors determines on what you're trying to prove. And that is essentially everything. As long as you can realize which type of proof you're looking at and what you need to do to prove or occasionally disprove it, then you should be able to answer these questions with relative ease.